In this Rhino Paneling Tools tutorial, I'm going to show you how you can use the paneling tools in Rhino to model these panels, as you can see here. First, I'm going to explain to model a simple surface in Rhino, and then I'm going to talk about the panels we can make. This can be a panel like a 2D panel, as you can see, a diamond panel. Then I'm going to explain the attractors. We can use point attractors to attract our grid or panels. Then I'm going to explain about 3D panels, which you can use the default panels in paneling tools, or also you can use your custom panel. As you can see here, my model is here, and then it's going to be onto that two surfaces, which I will explain later. And at the end, I'm going to talk about giving custom patterns. That is, let me show you. You can see it here, and I'm going to produce this pattern on the surface using the Manage Pattern tool. So basically, this tutorial will show you how to use paneling tools in Rhino. Okay, to get started, first I'm going to explain how to produce, as you can see, this surface in Rhino. So to get started, I'm going to start with a simple surface and draw a line in Rhino. And we can also draw a curve. I'm going to use the Control key to bring this up and down here. So we can simply make a surface by lofting these two curves. Let's just loft. And okay, and I'm going to bend this on a curve simply by using the flow command. So we can simply draw a curve, and now what I'm going to do is to put this surface from a base curve, which is a line, into this line, and that is the flow command. So what we can do is to draw a line here and connect from the middle of this by using the O snap to the middle of this, and this will be our base curve to the target curve. So we can now use flow, the object we want to flow. As you can see here, we have to use stretch to yes, because we want to stretch this because we want to stretch this line so the lengths are actually the same. So we're going to say stretch yes, and then the base curve and the target curve. Okay, and as you can see, we can produce this. So we can just simply make this a little bit bigger and then flow that. So I'm going to objects, and here we go. We can rebuild this into 30 to 30 and have a new surface. You can see this is going to move from a straight line on the floor up to this, and we can also deform this if we want. We can simply deform this surface. Okay, so now I'm going to explain how we can use the paneling tools. So let's just move this here, and what I'm going to do is, when you install the paneling tools, we have a menu here. As you can see, the paneling tools here. The first step into producing panels, it doesn't matter it's a 2D or 3D. I'm going to explain more about paneling tools in the course, but for now this tutorial is going to show you quick how you can use paneling tools in Rhino. So the first part we need is to create a grid. So first we need to create a grid. We're going to the paneling tools, create a grid, and as you can see here, we have different grids as we can make with the array, polar array, extrude along a curve, and so on. So the best thing you can use is to simply use the surface part and dismiss the other techniques, because if you have a base surface, this is the best and the most easy way you can use to create a grid. So we can use the surface part, and in the surface part there are those who are really important are the surface domain number. We will use this to define how many number of grids we need in the U direction and how many points we need in the V direction. So this is going to be the domain number. We can also define a surface 3D distance. This is also useful if you want to have panels which are exactly based on a distance. So if we define this maybe a 10, we will have a distance between 2 points, which is exactly 10. Okay, so you can also use this surface 3D distance, and we will also use surface domain variable because we want a variable grid. I'm going to explain these things, but for the chord or the lengths, you can also check it out yourself. It's not really important. It's the chord is basically the distance between those on the surface, and that's a chord one, and the length is the length of that. So now I'm going to go to the paneling tools, create a grid, and now I'm going to use the surface domain number. So this is the best one we can choose. You can see that we need the surface to be selected. Now I'm going to select this and right click or enter, and then you can see these points appearing there. Okay, there's a number of spans for U and V, and be sure to check the group to yes, so we can group those points. Okay, and as you can see, we will have 30. We can change that to 10, maybe 15, and we can change the V number of spans to 10, or decrease that. Okay, and you can see how simple it is to define the grid of points. And after accepting, you can see that those points will appear on the surface. So this is the first step in paneling tools. You have to produce a grid. After producing the grid, we can go to the paneling tools and use the paneling from grid, which is basically using the grid to panel, is to use these panel 2D and panel 3D thing. You can also use the orient and the panel planar quads, but we will not use this in this tutorial. So we're going to talk about panel 2D and panel 3D. Okay, so if you go to the paneling tools grid, panel 2D grid, you can see that you have to choose those gridders. Okay, the grid is chosen, and then enter. Then you have to choose the base surface, and now you can see that a set of panels will appear on the surface. So basically, the most important thing is the pattern. So you can just change that. We can have a box X. You can see this. We can have a triangle. We can have tree basic, a dense. You can see here. Diamond is really cool. You can see that you can produce diamond panels, and angle box, wave, and brick. So these are the patterns you can use. Okay, let's just do. I'm going to use diamond now. Now you can define which thing you want. The first thing is the panel shape is straight, and that means that those are lines, not curves. But if you just put the panel shape to pull or projected, it means that projected will project that in the Z direction, and pull will pull that into the surface. So these are a little bit different, and but for now we're going to use the straight. Okay, you can define which thing you want by these things. Okay, these inputs are going to be edges. Are you wanting the edges as the output? The face borders. The face border is a polyline defining this border, and the edge is simple edge line. A face, you need this face. You need a flat face if you want it, or a mesh. So you can see that I'm going to set edges to yes and everything to no, and the group and the layer, you can just set this to diamond. Okay, and here we go. So you can see that we have a layer here, diamond, and I can just choose this group, and you can see how easy it is to have this. Okay, if you want to have a complete diamond here, we can simply just change the number of the panels in the U direction. So let's just do this again. Paneling tools, create a grid, surface domain number, and I'm going to give this maybe 16. So be sure to put an even number in the U span. Now let's check this out to the grid, the paneling points, the surface, and now you can see that this is going to be a complete one. Okay, so I'm going to use this and have the edges, and also we can also have faces, Okay, here we go. We can turn off the surface and we will have the surfaces and the edges. So we can simply just move this in the Z direction by using the control key. I want to show you how you can simply produce the borders as the edges extrude. Okay, and we can go to selection, a last created object, and just change this to layer 1. And we can also change this to layer 2. And let's just delete these points. We can simply just give a material to this. So you can see that this is maybe a blue. It's a transparency. Here we go to the render. You can see this is a simple tool you can use. How it's really cool. You can give any surface a NURB surface and produce those panels. Okay, for the next step is how we can use the paneling tools to let's just go from the surface here. And for the next step, I'm going to talk about how we can use point attractors. So for now, we can also use a simple rectangle surface. Okay, and I'm going to rebuild this and use the soft edit surface to simply move the center a little bit up. Maybe we need a 70 and a 70 here. Okay, let's just move the corners up. I'm doing this to tell you that you can also have a NURB surface and not a flat surface. Okay, so here we are. We have this surface. We have to put a point attractor or a curve attractor on the surface to deform the grid. So basically, when you give a grid, the paneling tools will divide the U direction, okay, into numbers and divide the V direction into the number you give. So we can also have a grid that will be distorted by the point attractor or the curve attractor. So let's give a point here. I'm going to use the control key and go on surface and put this up. Okay. On the paneling tools, I'm going to go to the create panel grid, and now I'm going to use the surface domain variable. Okay. And as you can see, you have a distance method here. So if you click on the distance method, you can choose between the Gaussian curvature is the surface curvature, the mean curvature. We will have point attractors, curve attractors. A vector is based on a line or a vector. A random can be just a random attractor, and a bitmap is used as an image. So you can check all of those things out. This can be an infinite combination of point attractors and using the away method. Okay, so for now I'm just using a point attractor, and you can check out others yourself. So let's go to the point attractor, the number of the U and the V division. What happens to the grid is it's going to be attracted away from the point attractor or towards it. You can just check this out. Okay, towards. The magnitude is going to be 1, the distance of the magnitude of the attractor method towards. Okay, we can just put this 2.5 and the group yes. So we can select the surface and then select the attractor points. You can choose between different points, and then when you hit enter, you can see that the grid, okay, you can see that the grid is attracted towards that point. So now if I go to the paneling tools, and now let's choose custom 2D so you can understand this. Okay, we can simply go and maybe Control C, Control V, scale this a little bit and put this into the panel. So paneling tools, a panel from grid, a custom 2D, select the paneling points. Okay, select the base surface, and now you can select multiple curves as the panel. This is better if you want to panel your surface based on multiple curves. Okay, you can see that this is going to fit on your surface. You can change the length and the width here. So what will happen is that there's going to be a gap. You can give this a shift. A shift means that when you give a shift of 3 and a 3, you can see that these are going to be blank, and then each 3 of the grids will have the panels, so this is going to be 1 and 1, and you can also say that the curves are pulled on the surface. Okay, and now when I just hit enter, you can see that this surface is produced by these panels. Okay, so there's a little bit bug here, but you can just fix that by extending the surface. So, and that the problem was with the pull of the surface. So let's just check this out without using the pull. So custom 2D, let's choose the grid, the surface, and custom points. And now I'm going to put the pull curves to no, and here we go. So you can see that this is really important, and you can see that the pull curves sometimes will just have some problems on your surface, so sometimes you can just dismiss that. Okay, so this is the way you can use this, and you can simply extrude that. Okay, I'm just going to give you a sense of this custom 2D panel. Okay, so the next one which I want to explain is, let's get back to our surface and let's just zoom in. The paneling tools is also you have a 3D grid. So to produce the 3D grid, you can use different methods here, but for now I'm going to teach you one method you can use, and that is to use the offset variable. So I'm going to use the variable offset here, and variable offset surface will give you different thickness. So we're going to put what happens is that when you have two surfaces, okay, assume that this is a front view of that surface, so this is going to be something like this, and this is going to be something like this. What happens is that the panel will just go between those two surfaces, so you can define different thicknesses on that. And let's just do the variable offset surface, select the surface, and you can change the direction by using the flip. And now I'm going to work on those handles. Let's just bring this up. Okay, bring this up a little bit. So the thickness will just increase at these at this corner and will decrease at this corner. So then we can just hit OK and have two surfaces here, and let's just rebuild these surfaces to 30 and 30. Okay, now we're going to go to the grids and surface domain number. I'm going to click this. You can see that the corner is here and the number is just defined. Let's just increase. I'm going to change the 10. Maybe it's better to change this. Okay, 16 to 16, and again you can see that this corner is now here, and that will just make problems with your surface. So if I choose this, you can see that this is the first corner and this is the first corner of the second surface, and this will not give you results. Let's check this out. You can go to the paneling tools, go to the grid, and to the panel 3D grid, and let's just you can choose between patterns here. I'm going to choose partition maybe. What do you want from the output? So you can have edges, faces, solids, meshes. I'm going to give this solids and group yes. Okay, so the first point of grids, the second points, and as you can see there's a problem in the modeling, and that is because the U direction of this is here and this one is from here. How can we fix this? Okay, let's get back to this. Paneling tools, create a grid, surface domain number, and you can see this is the corner. Okay, now I want to fix this, so I'm going to go to the analyze direction here and reverse the U, because the U will just be from here to there. Okay, so I'm going to reverse the U direction and check out if it's okay. Okay, surface domain number, and you can see that this is okay. So this red one is the U and the green one is the V. So check this out and reverse the U or reverse the V or even swap UV. You can play with those and fix the paneling grid. Okay, so now we have the right to use that. So let's go to the paneling tools, to the 3D grid, and use the partition, and let's just choose the first one, the second one, and here we go. And you can see how simple paneling tools will produce the panels on the surface. Let's just put this to the rendered, or maybe technical or artistic, and you can see how simple it is to produce paneling tools on the surface. And let's just change this to a custom one. So maybe we want to put something like this on the surface. Copy paste this, scale this a little bit, and go to the solids and use extrusion. Okay, I want to use this panel, so let's go to the panel 3D grid. Okay, now I'm going to use the panel 3D custom 3D, and the 2D variable you can give different to the panels. You have to have point attractors, and the custom 3D is also like that. So let's just do this, have a 3D custom and the first grid, okay, second one, and now it just asks for the two surfaces. These are the two surfaces, okay, the object, that's what's happened. Okay, just hit the enter, and now we will have the results. So paneling tools is really easy to work with, and you can see, okay, we can just delete this surface and have this results here. Okay, so this is how you can panel a surface. You can use this in jewelry, you can use this for architecture modeling, and many other applications. So the last thing I want to teach and talk about is to, okay, let's just delete those things. I'm going to delete this grid too. The last thing I'm going to talk about is how we can manage the library patterns. Paneling tools has many tools. You can have grid utility, you have panel utility. Let me just explain a little bit about this. You can maybe trim a grid, you can convert to diamond or diagonal. So what happens when you convert to diamond? Let me show you. If I put a grid on this, surface domain number, okay, we have a rectangle grid here. So let's go to the grid utility and use convert to diamond and choose this, and as you can see, that grid will go into diamond. So you can also convert your grids to diamond by going to the grid utility. You can use tools for grids, and going to the paneling utility, you can extrude edges, unify face direction, offset face borders. Now, this is also good, so I'm going to show you now. Okay, let's go to the manage library patterns. I'm going to show you how you can manage the 2D pattern. So 3D pattern is exactly the same, but with a little bit of a twist. So let's go to the 2D patterns, and now we can have a 2D pattern, new one. Okay, new. Just click whenever you want, and wherever you click, you can just define. Okay, let's go here. We can define distance. It's not really important, but for now, the most important thing is this one. So a 2 and a 2 grid is exactly the same as the paneling tools grid, but now I'm going to give this a 7 and a 7 grid. So when we have a 7 and a 7 grid, the shift has to be 6 and 6, and that means 1 minus the number of the height and the width. And that is because when we have 2, okay, and perhaps we have a grid here, when we copy this, we just shift 1. But when we have 7, we have to shift 1, 2, 3, 4, 5, and 6 to put this point to this point. So this is really easy. You can just put this 6 and 6 and name this as star. I'm going to show you how you can simply draw a star on this grid, okay? This is going to be a polygon star here. And you can see how simple it is to, okay, right click to finish to connect those lines. So now I'm going to right click and then again right click, and that's it. So now when we just produce the grid, surface domain number, let's just put this to maybe 10. To have best results when you have 7 grids, you have to have a multiplication of 6 in your spans. So we will have a 6 multiplied by something to have the U numbers and the V numbers. So let's just give this a 30 to 30 maybe. And that is because each of those 6 will have a star in it. So let's just group them and go to the paneling tools and use paneling from grid. And now I'm going to use the panel 2D grid. So for the 3D is going to be panel 3D grid, but for the 2D and the library patterns we're going to the panel 2D grid. So now I'm going to go to the panel 2D grid, select the grid, select the surface, and now you can see that in the pattern section we will have a star. So you can also add some patterns in the library, and here we have it. We have this star here. Okay, so you can see that this is just produced on that, and you can produce that on the surface. And we can also split the surface with this. So I'm going to just use split and use these curves to split that surface into sections. And okay, so you can see that this will just split your surface into the sections. You can delete these things. Maybe you want the patterns in the middle. Okay, and we can simply use that to produce a surface. Okay, and then we can also, let's just do this. Okay, we can also go to the paneling tools and use the paneling utility and use the offset face borders. So when we go to the paneling tools and the offset face borders, you can have a distance method. It's fixed, so you can change that to point attractors, curve attractors, but let's go to fixed. And then the distance is important, and the make hole. So if I just put this to no, make hole to no, and maybe a distance of 2, let's check this out on one panel. And so I'm going to put this maybe to 1.5. Okay, so you can see that the distance was 0.5. You have to control that. And you can see that if you don't have a hole, it's just a simple curve. So now I'm going to again run this, but put this make hole to yes. The distance is okay. And now I'm going to select all of them. And here we go. What happens is that this will just make the curve border of that panel offset on the surface, and then just delete the inside of the panel. So this is a really good tool to produce borders based on your grid, as you can see here. Okay, let's just check this out. Okay, and here you can see that this is the results. Remember, the panels are important, so this is the problem with the panel. It can't offset that, so it just gave all the panel here. So we can just delete this maybe. If we don't need that, we can delete this. Let's just change this and delete this one. So you can see sometimes the offset is really important and can't produce on that surface. Okay, and now what I'm going to do, maybe delete those at the corners, and okay, and delete these ones. It's not really important, but I'm just going to use this, and then let's just delete these two. Okay, and now we can select them and connect them, join them together. They are going to be a simple single surface on that. Okay, and what I'm going to do is to use the offset surface to produce a solid. So let's just use the offset surface and put a solid on it. I don't know, the distance is 1 is okay, but let's just see. So you can see this is the offset, and let's just go to the artistic one, and you can see this is the results of that surface. Okay, so you can also use paneling tools to produce a structure on the surface, as you can see here, or on this one. And maybe we can also have those panels as windows or something like that. Okay, thank you for watching. If you have any comments about this, put below the video, and thank you for subscribing to our channel.